All right, we're going to try some more stuff here now. And what we're going to do specifically is look at some of these homework problems that were listed out here earlier. If we look at problem number 1 in the homework set, then it says compute the probability using the binomial distribution table. So for all these problems, you click where it says tables and go to the table, then you look up the number and you put it in, that's the answer. Okay? So this is just to get you familiar with what the table is actually telling you, how the table works. And certainly the table is easy compared to putting things into your calculator most of the time. However, as we did that other problem here, there are situations where those numbers don't work in the table, such as this one for number 2. If the probability, the general probability is 0.71, that's not on the table. So you can't do this with the table. Okay? So yes, you do need to know how to use the actual formula, which we've now done a couple of times. That's number 2. Okay. So then for number 3, we have a missile guidance system, and it has 7 fail-safe components. What does this actually mean? Well, if you're going to build something like a missile, you don't want it to break or mess up or go off course or something. So instead of just saying, I'm going to have 1 electric circuit for this thing, I'm going to have 7 electric circuits for this thing. So if one of them goes bad, the other 6 can still be used. So then you have all these different components so that if something goes wrong, then the other ones will take over. Okay? And then it says the probability of each one failing is 0.2. So then when we look at the problem and we say, okay, how does this relate to what we've had previously? Then we would be looking at this and we would say n is equal to 7. There are 7 things that we're looking at. That's our sample size. And then when we say the probability of failing is 0.2, then that would be the general probability. And it's specifically important to recognize that this means fail. So we ask the question, is this circuit failing? If it says yes, then that's what we're talking about. So when it says exactly 2 will fail, that means x is equal to 2. So then you would go through and do this problem using the same formula that we had before, with x equals 2, n equals 7, p is equal to 0.2. And as it turns out, this is on the table, so you could actually look at it that way. Now, there is something that if you want to say traditional statistics, we talk about other ways of describing the situation. And hopefully you understand that on the right-hand side here, if it says solve it, it'll go through and solve this problem for you. And then when you click back, it'll change the numbers. And then you would work on a different problem. If you click where it says show example, then it's a problem because I've signed out of my thing here. So I need to get back here, go to my assignments. And this can happen to you too. If you just go away from the computer for a while, then it kicks you out and you can't get new stuff. But now I'm in, so hopefully if I go back here and hit show example, it won't. So back I go, preview assignment, start my assignment, question 3, and now it's changed all my numbers. So now it has 6. The probability is 0.05. And it said exactly 2 will fail. So that's the same thing. Okay. So this was for part A. So then when we say, okay, if I go to show me an example, then that's what it's going to do. It's going to show me my example. When it says more than 2 will fail, if I say more than 2, how many numbers are more than 2? 3, 4, 5, and 6. No, I don't care. Now, it's possible for me, if I say more than 2 will fail, I could actually go through and use the formula for these 4 things. I would have to do the formula 4 different times. Now, I decided not to put this question on the test because that would take a while. So then I'm just going to have you do it once. But that's what would have to happen on the homework, is that you would have to figure this out 4 times. But if you looked at the view example thing, you would recognize that these things are on the table, so that you wouldn't have to go through and figure each one of these separately. You could just look them up on the table. And if you do, then you're finding the probability that this could happen, or this, or this, or this. So then you would find the probability for each one of these, then add them together. Because when we say more than 2 of them fail, then we would add up those, because it could be this or that or that. So we add those up. And then when it says all of them will fail, okay, is it possible that all of them would fail? Well, all of them would be 6, so that would be 6 out of the 6. And again, if we put that into our calculator and get the formula, we could do it that way, or we could just look on the table, and it's 0. It's really small, so that's 0. And in the instructions, it did say to us that we needed to round the answers to 3 decimal places. Just as a reminder, when it says round your answer to 3 decimal places, that does not mean while you're doing the problem, round to 3 decimal places. You need to keep your answers that are in your calculator and not round them off if you can help it. And like I showed you on here, you need to believe what your calculator is doing. When you hit those buttons, it's going to give you a number, so you don't have to write down a bunch of 10-digit numbers as you go through the process. But when you get to the end, that's where you round off to 3 decimal places, and that rounds off to 0 here. Question?
When it says round to 3 decimal places, so on one of the homeworks I had it happen, it was like the answer ended up being like, you know, point something and then like 0, 0, 0. But when I just put in like 0.4, I don't remember what it exactly was, but like 0.4, it was like no, so it made me put in the 2 zeros. So on a test, would you still, if it says 3, you want the zeros added if it's all 0?
No. All right, so then when we say compare the answers for parts A, B, and C, explain why the things are reasonable. If one thing has a low probability of failing, then 2 things failing would have an even lower probability. And then all 3 of them failing would be even lower. So as you go to more and more things, chance of them failing goes down. So that was the point of that question. All right. Just so that you're able to go through these, this is not exactly what's going to be on the test, but having it on the homework here hopefully gives you an idea of what's coming. Because in the future, we're going to have something like more than this. And if it's more than that, then it's from that and more. So that's what we're talking about here. Okay. Number 4. We're taking a multiple choice exam. It has 2 choices for each question. And we're trying to, bless you, we're trying to figure out what are the chances of getting a certain number correct. Okay. So this is an exercise for you to recognize what are the different ideas for n, p, and x. So if we're talking about what we want to measure, then we're looking at getting correct questions. So we're asking how many correct questions out of a certain amount. In this case, 11. So then n would be 11. That's the number of questions that we have totally. And then when it says we have 2 choices for each question, then that means the probability would be 50%.
It's typically 0.75 because there's another. That's 2 choices plus you guess on each.
No.
Each question. What's that?
When you have a question, here's question number 1. There are 2 choices, A, B.
Because the one I answered, I had to do 0.75, so I started with 50. So maybe it's a different one then.
You might have said that it has, well, no.
That's what I had to do.
All right, when you say how that works, the only way that I can see how that would work is that if you had 4 choices for each question, and then you're guessing, it would be 0.25, but not 0.75, so that wouldn't make sense. The number of choices that you have would determine what this probability is. If it's 2 choices, it'd be 50%. If it's 4 choices, that'd be 25%. Now, if you say, it made me do 0.75, that would be wrong. So I would have to look at that and make sure that they're not doing that, because that's not how it works.
That's what I had to do to even get the answer right, because I tried the 0.5 and it said it was.
Okay, now I'm not going to argue with you right now.
I won't.
Okay. Okay. I can't resolve that right now,
Okay, that's fine.
but it is not right that it was 0.75.
Yeah.
Okay? So there's something wrong with the software, or maybe it was 0.75 and you thought it was 0.25.
I just want to make sure I get the answer right if I have to do something else. That's why.
Okay. So I'm going to write this down, and after we get done, we'll talk about it. All right? Because I can look at your exact question and see what it says.
Yeah.
All right? So when I'm looking at this right here, the number of choices is telling me what my general probability is. Since I have 2 choices, it's 50-50. If I had 10 choices, it would be 1/10 or 10% for each one. And then I'm guessing on each question. And since I'm guessing, then that means each one of those options is equal. Okay, that's why it's 50-50. And then when we say at least 7, then we need to ask the question, how many is at least 7? When we say at least 7, this would be 7, 8, 9, 10, 11. So again, that's why I didn't put this question on the test, because that would be a lot of work for you to go through all 5 of these things to say, I want to add all those probabilities together in order to get at least 7 out of the 11. Now, if we look at the example, all right, then it has it here. Again, it's 2 choices for each question. 9 out of 13, which would be 9, 10, 11, 12, and 13. And once again, it's a lot easier to do this problem on the table. You don't have to do any figuring. You would just take these numbers that are on the table and you would add them up. So when you're doing this homework problem, if you haven't done it already, I recommend that you use the table. You don't have to actually go through and figure each one separately. Okay. So that is question number 4. Did somebody have a question on this or not? Okay, question number 4. Question number 5. 26% of couples are planning destination weddings. Assuming this is binomial, either they're going to have a destination wedding or they're not. In a random sample of 5 couples, find the probability of the following. So it's the same kind of an idea, but now we have to figure out what N and X and P would be in this. So if I have 5 couples, N is equal to 5. When we say that, what's the general probability that they are going to have a destination wedding? That would be 26. So P would be 0.26. And then from the different questions here, at least 3 couples would mean X is equal to 3, 4, 5. Now in this situation, you can't use the table. The table doesn't have that information. So you would actually figure each one of these separately using the formula, and then you would add those numbers together to get the total. Now, it's sometimes difficult for me if somebody has a question on a problem like this, and if I say, okay, what is your question? What did you not know how to do? If they say, I didn't know how to do any of it, okay, then hopefully we've gotten to the point where you now understand that, right? That you use the formula, just like what we had before. You put these numbers in, you put them in on your calculator, you get these numbers, and then what I just said is you add the results together for these 3. Because it could be, when we say at least 3, that means it could be this or that or that. So we add those numbers together. So hopefully I've gotten you to the place where you know how to start the problem. You identify N, X, and P. You put them into the formula, and then the last step would be to add those things together for this particular problem. This question.
I'm sorry, I'm really confused.
That's okay.
Like how can we use that formula if we don't know what X is?
Okay, right here, when it says at least 3 couples will have a destination wedding.
Okay,
Okay.
so then that is our X value?
This is the X value. Actually, it's not just one X value,
Okay.
but it's 3, 4, 5, because there are 5 of them.
Okay, I see.
Okay? And so then we would do this, 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 and then we would add those results together.
Thank you.
Okay, sure. And that's a great question, by the way, because that's a very basic thing which isn't always clear. All right? Okay, so we've got the at least 3. When it says exactly 3, okay, that would just be the thing we've already done, which was X equals 3. So it's just that thing by itself. And then fewer than 3 would be 0, 1, 2. That's fewer than 3. And it's also true that if I know this amount, then this would just be 1 minus that. If I know what this is, then this would have to be what's left out of 100%. We'll do a lot more of that kind of problem later. So I'm not too worried about that right now. But I want you to see how these homework problems go, at least. All right, so that was number 5. So now we need to talk about number 6. So this is the situation when we're talking about the mean and the standard deviation. And so we're leaving aside the formula that we had before. We're not using that formula right now. We're looking at the mean and standard deviation. So still binomial. We have the dehydrated children. They're still out there. So I'm going to do this. I'm going to toss 15 coins. So n is equal to 15. And then the question I have here is asking me what is the mean? And what we're dealing with is that x would be the number of heads. So then the mean from the formula is n times p. And if we say what's the probability of having something full of heads, that's 0.5. So this would be 15 times 0.5, which is 7.5. So what happens if I have 15 coins? I should have brought them. If I had 15 coins and I just drop them on here and I count the number of heads, what will I expect? What will I see? Well, it won't be all 15, more than likely. It'll be somewhere in between 0 and 15. But what would be the average if I kept doing that? I grab the 15, shake them up, drop them, count. Grab the 15, shake them up, drop them, count. How many heads would I get on average if I did that a bunch of different times? This goes back to the idea of the expected value, the long-term average. It would come out to be 7.5. Now, if I look at that on my graph here, and I say, okay, I've got 15 coins, and my general probability is 50%. This is what that looks like. It looks like a bell shape, pretty much. Will I get 7? Oh, I will, yeah. Will I get 8? Well, that'll happen. I can get 9 or 10, sure. But then as I go out here, it gets less and less, and so then these would be unusual values here, and these would also be unusual values here. Would I expect to get only 3 heads out of 15? No, that would be unusual. It could happen though, 1% chance. So this kind of a problem is telling me what the average is. This is the average value of x. Well, what about the standard deviation? Standard deviation is the square root of n times p times q. And if you put that into this formula, you'll come out with 1.9. What does the standard deviation measure? Somebody tell me that? Maybe we should have the coffee shop open in the afternoons. Maybe that would help us stay more awake. Liz?
The variation of the data.
Okay, the variation of the data. There's another phrase there.
Data set from the mean.
Okay, the variation of the data from the mean. So if we look at the mean, 7.5, and then we look at this, 1.9, it's telling us something about how far it is away from the mean. Okay. So this is what I want you to understand about this distribution. If the standard deviation is greater than 3, then we can use the empirical rule. Only for binomial. Only in the situation where we're using a binomial distribution. If we have a group of people, and we're asking them a yes or no question, and I know the general probability, and if I figure out the standard deviation and it's greater than 3, then I can apply the empirical rule to my situation. But all those things have to be true. Question?
What is Q? In this one, what's
I'll allow your friends to tell you. 1 minus p. Q is 1 minus p. Okay. So, let's say I've got dehydrated children. 14% chance that these children have dehydration. But let's say I have not just a few children, I have 200 children. N is equal to 200. I have 200 children in my school or in the district, whatever. I don't know, like 300, 200. You want them to all be kind of the same grade because there's different things going on. So let's say we're talking about in a specific school district, there are 200 first graders. And the general chance that any of those children would be dehydrated would be 14%. So I want to know what's my mean and standard deviation. Can somebody work that out for me?
28?
Mean is 28. Okay. I get 4.9, so yeah. So we'll say it's roughly 5. So I'm going to use the empirical rule. What will the empirical rule tell me about this situation right here? Okay. And what would those numbers be? You'll get back to me on that. All right. Hunter, can you tell me how I would find the range of numbers for the empirical rule in this situation? Okay. Kayla, can you tell me how I'd find my numbers for the empirical?
Pass.
Okay. Caitlin, can you tell me how I'd find my numbers? Okay. So I want to know what the empirical rule says. Let's start there. Liz Thomas, can you tell me what the empirical rule says? Okay. Mariah, can you tell me what the empirical rule says?
I don't know, is it useful because it's spell shaped?
Well, it is. That's one thing. That's a good part of it. I like that answer a little bit. Just a little bit, not very much. All right, Katie, can you tell me what the empirical rule says? All right. The empirical rule, very important. I want you to know what it says. It should be in your notes about half a dozen times.
It allows us to predict the usual values, 90% of the data will be in this interval.
95% will be in what interval? Hunter, you got that number? Or those ideas, I should say?
95.
Okay, 95% of the data is in a specific interval, and I want to know what that interval is.
So what we can expect.
It is what we can expect, but I want to know, how do I find, when I say interval, and this is something that happened on the test, by the way, when I say interval, I mean there's a number on the low side and a number on the high side. That's what interval means. Okay, so I want to know how to find the number on the low side and the number on the high side. Kayla, you want to tell me?
You take the mean minus 2 and the mean plus 2.
No. I take the mean minus 2
Times
times the standard deviation, yes. Okay. Now, we are going to talk about this a lot. So if you want to write it down again in your notes right now and put a star next to it and say, this is what the empirical rule says, and we're going to go over it again a lot. That would be good. Okay, because the empirical rule is good to know, it's important to know what it's actually saying to us. And it is. You take the mean minus 2 standard deviations, that gives me the low end of the interval. The mean plus 2 standard deviations gives me the high end of the interval. And that will tell me, as Melissa said, what to expect. So, what numbers am I going to get from this situation? My mean is 28, the standard deviation is 5. What is the interval for the empirical?
18 to 38.
18 to 38. So, Crystal, can you tell me the full statement of the empirical rule?
So you could expect anything between 18 and 38, and anything below 18 would be unexpected, or above 38 would be unexpected, but there's a way to make that not so wordy.
No, you're fine. We expect the values to be from 18 to 38. Anything below 18 or above 38 is unexpected or unusual. I am able to use the empirical rule in this situation because my standard deviation is greater than 3. And I'm using the binomial distribution. For the binomial distribution, if the standard deviation is greater than 3, then we can use the empirical rule. My standard deviation is greater than 3, so I can use the empirical rule. So now I know we expect from 18 to 38, below 18 or above 38 would be unexpected or unusual. What are we measuring? They told me this one of my teaching classes. Stop talking and let people think. So I just did that. I stopped talking. What are we measuring? The number of students that are dehydrated. We expect that number. Be between 18 and 38. If it was below 18, you'd be surprised. If it was above 38, you'd be surprised. What's 14% of 200? 28. That would be how many on average we would expect. But we would not be surprised if it was as low as 18 or if it was as high as 38. And if we look here, we can see 28 is right in the middle. 18 to 38 would be like this. We would not be surprised by any of those things because that's where the 95% is. Again, this is one of the most important things you'll ever hear in statistics. When we ask the question, what information do I get from this? It's not a single number answer. How many children will I expect to be dehydrated? The answer is not 28. The answer is from 18 to 38. So if somebody says, well, you know, we're only supposed to have 14% dehydrated children, and that would be 28, and we've got 35. The answer is, okay. That's not significantly different from what we expected it to be. That's within the range of what we would expect to happen. It's not a crisis if our numbers change, because numbers change. We're only taking a sample here, and just because the sample is a little bit higher than we exactly expected it to be, it's not a crisis. These numbers change because they are samples. And this is exactly the mathematical formula way of making this clear. The assumption is here that it's not like one child's dehydration is related to another one. They're just all independent, random things happening. Somebody gets dehydrated for whatever reason. And so then, when we look at this, we say, if these are random numbers just generated, then we would expect that it could be anywhere from 18 to 38. That would not be a crisis. That would be within what we would expect it to be. Either higher or lower is not an unusual value. But if it gets to 17, then we say, oh, that probability is pretty low. And if it gets down to 10, we're like, wow, these are really hydrated children. What do you do, spray them with a hose? I don't know. But that would be a low number. And if it's higher than 38, we would say, well, we should be concerned because we have more than we could expect to happen. Something must be wrong. They're outside for too long in the hot sun. So this process of understanding how this works is a key to actually knowing what statistics tells you. When it says what to expect, it's a range of values. And that's what we have here. So then this is how we can control our variation, okay? This was 200. Well, what if we wanted to have a more exact understanding of this, okay? Well, if we had 2,000 students, you know, that would be a little bit different. And so then we would have maybe less of a thing going on here. This won't do it actually. If I put in 2,000, it goes nuts. But some of this some of this variation in things is just based on the mathematics of the situation. you don't actually know it's going to be 28. When you throw the coins on the table, you don't know how many heads you're going to get. That's just the nature of the thing. So you have to understand that these numbers can vary either higher or lower. All right, so what does that look like on the test? It looks like this. Consider a binomial distribution where it has this for n and this for p. Find the mean and standard deviation. What would be unusual values of x in this situation? We would use the empirical rule, and we would find 2 standard deviations below, 2 standard deviations above. Unusual values would then be anything outside of there. And I put a note in here, yes, this is bell-shaped. So you don't actually have to remember the greater than 3. I'll just tell you, it's bell-shaped. All right, so what we have just done is gone through all the homework problems and all of the practice test questions using binomial distribution. Okay, now those are not the only things that are on the test, right? Because we've got this stuff here. We've got the socks out of the drawer. We have having people on the bus, how many percent of the time. We have going from observed probabilities or observed numbers to probabilities. We also have this, what's called the discrete probability, find the mean and standard deviation. So all those things are also on the test. Now, we did all those things 2 days ago, so I don't think we would necessarily have to go through all those things again. But, yeah, it's kind of crazy. Let's just do one standard deviation problem using this stuff. Oh, and I wanted to mention something that we've gone over earlier. So I'm going to put this up here, and we'll do a mean and standard deviation based on this. So let's say that we have the number of customers and this is what we're going to assume. We'll have 40 customers. The probability of that happening is, let's say, 10%. And then we say, well, we could have 50. Probability of that happening would be 70%. And then we could have 60 customers. Probability of that happening would be 20%. Okay. So I want to know the mean and standard deviation for this. So let's see if we can make that happen. All right, check with your neighbor, see what's going on with your neighbor.
I got so messed up because I was looking at, that's right. But I was super messed up because all the other ones we did the other day were like.
Yeah, I know what you're talking about.
Yeah, it was like the,
So this, he basically just cut out this part and you just cut this.
yeah.
So you don't have to do the extra step here at all.
Oh, okay.
So like, remember when we add them all up and divide for them?
Right, and that's what I was trying to do.
You didn't have to do that, this is already written up. Or relative, P of X is relative.
Okay, so then we just do this part. So
Yes.
51 is what you got to.
Yes.
Oh,
And
okay.
square times.
Yeah, I didn't get that far.
Yeah, and then you'll do the standard deviation.
Okay.
So, so he didn't give you the frequency, he gave you the number of customers and the frequency, he just gave you the number of customers and then.
Okay, so we don't even have to deal with, okay. Okay.
All right, Mattia, you got something to like? Yeah, what do you have for the meeting? 51, okay, how'd you get that? Mm-hmm. Okay, that's right. So the formula for the mean is the sum of the x's times their probabilities. And so then that's what we do. Now, previously, we had had a situation where I gave you the frequencies and you had to find the probabilities. But if you look at the practice test, that's not what happens. On the practice test, I give you the probabilities. So that's what I'm doing here. There's a separate question where I ask you to find the probabilities based on the frequency. So I made them two separate questions. The first one is, if you have the frequencies, find the probabilities. The second question is, if you have the probabilities, how can you find the percentage? Now, if you'll notice, when we originally did the mean, we said we would just add up the numbers. So that would be like 40 plus 50 plus 60 divided by 3. If I only had these three numbers, 40, 50, and 60, and this was for separate days, like I had 40 customers on Monday, 50 on Tuesday, 60 on Thursday, and I just added them together and divided, that would be the average. But that's not what I have. I have a number of customers, and then I have my probability, which says this is how often I expect to have 50 customers. This is how often I expect to have 60 customers. So I expect to have 50 customers most of the time. Every once in a while I'll have 40, and sometimes I'll have 60. In that situation, if I want to know what's my average, then I have to use this formula. The way the data is given to me determines what formula I'm going to use for the mean. So in this situation, if I have, instead of just the number of customers on 3 different days, if I am given the probabilities, then that's telling me 50 is more common. Every once in a while I have 40 or 60, but this happens most of the time. And so then I use this formula to calculate my average based on that. Okay? Now hopefully you can see it makes sense. 51 is just a little bit more than 50 because I have 60 people a little bit more often than I have 40. So that makes it a little bit different. But now I need standard deviation. Okay. Emily, can you tell me what I need to do to get the standard deviation?
We take x squared times p, so the first one would be 40 squared times 21, which would be 160.
Okay.
Second one would be 1750
Okay.
and 720,
All right.
and then you would add those up.
Okay. And that goes into this formula where I have the sum of those probabilities, or these figured out things, and then subtract the mean squared. So that would be subtracting 51 squared. So what do you get for a number for the standard deviation there, Emily?
5.385.
Okay, and we can go with 5.4 probably. Okay. So that's what that is. What does the standard deviation measure? If I ask the question, what does the standard deviation measure? What's the answer to that question?
Measures the variations of the data sets from the
Measures the variation of the data set from the mean. So if I'm looking at this, the mean is 51, that's pretty much in the middle. And then if I have 5.4, I can't really use the empirical rule here because I don't really know for sure if this is bell shaped. But if I think about this as like 10, if I was 2 standard deviations, that would be 10 either side. And that seems reasonable. So at least it's a reasonable number. It's not an exact thing with the empirical rule or anything, but it seems reasonable in this situation. All right, so that's all we're going to do today. If you have other questions, that's fine, and I can answer them individually. But yeah, so next time we get together, we'll be moving ahead a little bit, and then we'll have the test over binomial.